If we did, we'd keep it. If we didn't, we'd pitch it back in the hole and bury it with the rest of the stuff. Well, when we washed the stuff, we found that there was a whole bunch more Edrios on those slabs than we were feeling with our fingers. So then we started taking everything out and cleaning it later. And Dave will probably appreciate this little structure right here, a little it looks like. We'll talk about that later too. Now, this is an Edrio from the site, nice Isoropus. Toothbrush water. Some of these responded to Quad-O, if you ever had that available, which is a super strong detergent. It's that clay to come off. That's it. Nothing else. No fancy equipment. Now here, we have a don't do. This is someone, I've been looking for some images. I stumbled on a person on the internet selling Edrioasteroids, some from Cincinnati, some from elsewhere. These are Cincinnati ones. And apparently this person, you know, likes to get money for them, and he's got enough money to buy an air abrasive, but not enough sense to know how to use it. And he's either using the wrong materials, or again, doesn't know what he's doing. But time is money, so I'm sure these cleaned off very quickly.
Yeah.
But what he's done, he's actually polished this one, which removed all the surface features from it. This one's actually blown a hole here in the shell, and partially in the Edrio. These are toast. They're not worth 40 cents. So if you happen to find some really nice specimen, and it's something beyond your ability to clean, and you need something more, and you know someone who has an air abrasive, say, if that's what you think is needed, make sure they know what they're doing. Not everybody does. So it's a little speech, cautionary speech there. Now, just a few more examples. There were some really big Edrios. These, I guess that bigger one is about an inch, there's maybe 3/4 of an inch. They got as big as about 35 millimeters for the Isoropus, which are the ones that got the biggest. I think that's, I don't know, what's that, inch and a quarter, inch and 3/16, something like that. The bigger they get, a lot of times you'll find them even other places. It's all disarticulated. You can't see the structure very well. You see these two here are actually fairly nice considering the size. And they also got really small. Again, there's a 2 millimeter one and a 1 millimeter one here. There's one that I don't have photographed that's 0.6 millimeters. That was going to determine it was an Edrioasteroid. I can't tell you what species that is, but I do know that it's an Edrio. And looking at this one here, you see there's multiples here. There's obviously that one here, one here, one here. Not sure about that from the photograph, hard to tell. But these two here are Carniella. Now, if you'll remember the one I showed earlier, the ambulacra are all nice and curved around. This little one, those ambulacra are almost straight. And then this one that's bigger, they're starting to curve. That's just part of the way they grow. They start out, those little things pretty much straight out. There's a growth pattern to all the Edrios. And again, you can still tell these are Carniella because those ambulacra look like zippers. Now, and again, there's the same one, that's the same Carniella. I'll show you that one throughout here because that's the best one I got here. There are some others and smaller ones. That's probably the largest one too. There's another Streptaster. And you can see why I can't see the anal structure there. It's just everything's all intertwined. As far as counting, I counted all my specimens, literally. Stu didn't do all that kind of data collection that I did, but in this population that was the part that I collected, 3% were Carniella, 3% were Streptaster, the other 94% were Isoropus of all sizes. So, having collected all this stuff, we thought, wow, we got something here. And this was similar to material that you see excavated over near the Florence Mall, which a lot of you have seen here. This has been on display, and Dave Myers has spoken about it before. This was similar to that. We thought, wow, maybe somebody wants to do some research on this and compare it to Florence and all that. And that was something we thought was very possible. So I had time. I decided to do a bunch of data collection. And it was pretty extensive. I'll show you in a minute some of the data sheets. But site data, I went back and tried to figure out how much area we'd excavated and what these Edrios were on, where they were, and so on. My part of the collection was just under 2,000 Edrios, 1,800 or some number like that. My guess is under certain years like that, individual Edrioasteroids. I'm guessing Stu's quantity was the same, very similar. So together, we're saying maybe 3,600 individual Edrioasteroids over about 600 square feet. It guesstimates about 70 per square meter, which is much more densely populated than the other site, Florence site. So here's some of the data sheets just to give you an idea of what I did. I decided that anything I could pick up in my hand, and I called it a slab, whether it was like this, just a Raphnaskina, or if it actually was a slab with something on it. And I identified it with a number. And then on that, I identified the Edrioasteroids if I could, and designated them. This is like IO1, IO2, IO3. Those are Isoropus 1, 2, and 3. So then I put them in a chart like this, and you can see that like that 1026, the first one's a Carniella, and there's a bunch of X's. Well, I knew they were Edrioasteroids, but I couldn't determine myself what the species was. So I had put an X. I wasn't going to guess if I couldn't tell and convince myself. We also have located them if they're on, especially if they're on a Raphnaskina. I used this scheme here that David used in Florence, how to locate them, measure the shell, where are they on the shell, how big is the shell, are they at what angle to the horizon, if you will, are they, and how far out. So you could actually take this data and reconstruct, a theoretical Edrioasteroid on a Raphnaskina shell. So everything is numbered. Even these specimens you see up here have numbers on them, and they can all be traced back. And at this point, what I did was I donated a goodly portion of this to UC. I kept all the Streptasters, but and I think they said they've done some work on them over the years. But we were hoping something else would happen, and the other thing that happened was they moved all the collections to the Geyer Center. So now this collection is at the Geyer Center, and Colin Summerall has some students that are doing some work on this stuff right now too. And here's some more recent work that Dave has done with Ben Datillo, and I presume these other two folks are students.
Well, Gainer's a student and Dewing is a Canadian paleontology student.
So because he's Canadian, he was last? Okay, well anyway, these four folks did some research based on some other work that Ben had done with Sourbiel, noticing that it looked like these brachiopods actually didn't want to be buried alive, and they were struggling to try to keep from being buried. And they call it sediment avoidance. And Dave gave us a talk here, I think within last year, about this particular work. And he showed us a poster presentation to describe that. So and that's what this is. This is a specimen from that study. It's from my site. Lots of nice Edrioasteroids on it. So now Dave has asked me to join with he and Ben on a new project, and we'll probably cover one or both of these areas of study. The raft paleobiology, which we'll be talking about this sediment avoidance and maybe other things, such as the life position. Always been a thing that we've wondered about. Which way does a Raphnaskina live? Convex up, convex down. Edrioasteroid position on the shells should dictate to us what that is. And still, even though you see some different specimens, you still wonder. On Edrio level, preferred attachment location and possibility of Edrioasteroids moving or relocating. So, do Edrioasteroids like to live on? The common knowledge around here is they love Raphnaskina, and they specifically like to be around the margin of the shell, the commissure where the shell opens. The idea is so it's a feeding advantage when the brachipod is open and he's feeding, he's creating some water currents. The water currents are helping stir up stuff for the Edrios, who are also filter feeders to feed on. So it sounds like a really good thing. So you do find Edrioasteroids a lot of places, and here too, where the Edrios are right here around the shell opening. And a couple nice Streptasters. Over here is an Isoropus. The shell is kind of buried in this case, but that margin's down in here. He's pretty close. He's a good size one. So we're going to count that as being near the shell margin. So that's the ideal. They really like this. That's what we've been hearing. So there we go. Now these would tend to be. This is also from the site. Sorry about the colors. And you do some emergency photography with a different setup. But these would be less than ideal. Here you have Edrioasteroids around the margin, but you got some back here. One there, one there, one there. This guy's got one back here at the hinge line. These guys technically here at the margin, but you still got some back from the margin. Well, you know, if they like to be by the margin, you know, why are these guys doing so well? I mean, this guy's quite nice size. He seems to be doing just fine away from that margin. So let's see what else they are living on. In this case, this is just a busted piece of a central valve for the rapid skin. It's the inside of the brachial valve. So we know that guy was dead. And there's 3 Edrios on here, all isotrophous, one little bitty one and two larger ones. This guy, like this previous slide,